Hello, good day everyone. Today we are going to continue our topic, the non-exact differential equations. And before proceeding now to our topic, please don't forget to subscribe to my YouTube channel. And as you can observe no, in our previous lecture, I'm discussing there the direct solution of the given non-exact differential equations in which we are using the integrating factor phi, and then after that we check no the non-exact differential equations if it is already exact, and by that we proceed no with the direct solution, and we have now this answer for that given non-exact differential equation. Using the direct solution, we have this answer of x minus x raised to the negative 1 y squared minus x raised to the negative 1 plus y is equal now to c. Okay, so now we are going to use the indirect solution no, for this case, in which as you can observe no, in our previous lecture, the part 1 of this video, that our integrating factor phi is just simply equal now to the x raised to the negative 2, and by this we use this one no, as a multiplier to this given non-exact differential equation. So from this one we have here x squared plus y squared plus 1 dx plus this quantity x squared minus 2xy dy is equal now to 0, and then we multiply this one no, the whole equation by this phi no, which is x raised to the negative 2. Okay, so after this simplifying this one, we have arrived no, to this given terms. We have here 1. So if you multiply this x raised to the negative 2 by this one, so it is x squared over x squared or 1. Okay, plus next is we have here no, x raised to the negative 2 times y squared. So it is just equal now to x raised to the negative 2 and then y squared, and then the next term will be x raised to the negative 2, and this is dx. Okay, plus this term here, so we have 1 minus 2x raised to the negative 1 y is equal now dy is equal to 0. Okay, and then by this form we can identify no our m variable no from this form that we multiply the non-exact differential equation with this integrating factor. So we have now this new form of m, which is equal now to 1 plus x raised to the negative 2 y squared plus x raised to the negative 2. And for our n, so we have this n equal now to 1 minus 2 x raised to the negative 1 times this y. Okay, so we are going to determine the partial derivative of m with respect now to y. Okay, so try to remember no, if it is with respect to y, we use this y no as our variable. Okay, so the partial derivative of a constant is just 0, and then plus we have now this x raised to the negative 2 y squared. So y as our variable, so we have now this from this we have here 2 times y. Okay, and then this is 2 minus 1, so this is just 1 no, or we just put 1 times this x raised now to the negative 2, and the third term is plus 0. Since our variable is y, so this is probably a constant, no? If we are dealing with the partial derivative, no, of m with respect to y, so this is just equal to 0. So therefore, our partial derivative of m with respect to y is just equal now to 2x raised to the negative 2 times your y variable. Okay, so how about for this partial derivative, no, of n with respect now to x? So here x as our variable, and then the partial derivative of a constant is just 0, and then we have minus. Since to make this clear, no, so our x is the variable, so we may write this one into this 2y, and then this is x raised to the negative 1. Okay, so this is our variable. Okay, this is our variable, and then we consider, no, we consider this 2y as our constant. Okay, so taking the derivative, no, of this 2x raised to the negative 1 times y, or in this form 2y times x raised to the negative 1, and x is our variable, so we can say that this is just 2y and then x to the n, no? So our n is just negative 1, so this is n, which is negative 1, times x raised to the n, which is negative 1, minus 1. Okay, and this would be here. Okay, so this is just negative 2y times negative 1, so this is positive, no? 2y, and then this is x raised to the negative 2, or we can say that our partial derivative of n with respect to x is just simply equal now to 2x raised to the negative 2 times y. Okay, so by this, our partial derivative of m with respect now to y is just equal now to the partial derivative of n with respect to x. So this is already an exact, no? This is already an exact differential equation. So that is why we proceed, no, with our direct solution, and we arrive, no, with this answer of x minus x raised to the negative 1 y squared minus x raised to the negative 1 plus y is equal to c. Okay, so this time we are going to use the indirect solution. Okay, so proceeding, so you have to remember, no, that we have two forms of using the indirect solution, and the first one is this integral of, no, integral of m dx, and then plus your f as a function of your y is equal to c, or you may opt to use this another form, integral of n dy plus your j as a function of x is equal now to constant. Okay, so now we are going to use, no, using the integral of m dx plus f function of y is equal to c. Okay, so substituting our m here, so we have here integral of this 1 plus x raised to the negative 2, and then this is y squared plus x raised to the negative 2, and then this is dx. Okay, plus we have this f as a function of your y is equal to constant c. Okay, so proceeding, So we just have to write this m and n, no? Before we will erase this one. So our m is just equal now to 1 plus 1 plus x raised to the negative 2 y squared plus your x raised to the negative 2, and your n is just equal now to 1 minus 2x raised now to the negative 1, okay, negative 1, and then this is y, okay. So proceeding now, so we have here the integral of, we distribute now the dx, no, and the integral. So integral of, we have here integral of dx, okay. So let us write, no, the integral of your dx, and then we have here x, no, with respect to x, so dx. So we have here the integral, no, plus, so we extract the y squared, so y squared integral of your x raised to the negative 2 dx, and then we have here the integral of your x raised to the negative 2 dx, okay. And then this is plus your f function of y is equal now to the constant c, okay. And we have here the integral of dx, no, is just simply equal now to x, no, x plus the constant c1, then plus we have here y squared integral of this one, no. So we have try to remember, no, the integral of u to the n du is just equal now to the u to the n plus 1 over n plus 1 plus constant. So here our n is just equal to negative 2, and our u is the x. So we can say that u to the n plus 1, so this is x, our n is negative 2 plus 1, okay, over n plus 1, okay, plus constant. So in this case we will use c2 as our constant, okay. And then the third term is we have this same, no, x raised to the negative 2 dx. So this is equal now to x negative 2 plus 1 over negative 2 plus 1 plus c3, okay. And then we have here plus f function of your y is equal now to the constant c, okay. So simplifying, so we have here x plus c1 plus this y squared, and then we have here this would be x to the negative 1 over negative 1 plus c2, and then plus we have here x to the negative 1 over negative 1 plus your c3, okay, plus your f function of y is equal now to the constant c, okay. So after this one we are going to separate, no, the constant. So this will be x, no, plus c1, and then this would be, you distribute this one here, so plus y squared times this one, okay. So this would be negative, no, so we will use the minus sign, no, since positive times negative is just negative, no? So this would be minus, this is minus x to the negative 1 y squared, and this is plus c2 times y squared, okay? And then this is negative, no? So minus x raised to the negative 1, and then this is plus c3 plus your f function of y is equal to c, okay? And after this one, we separate to the constant. So we have here x minus x raised to the negative 1 y squared, then minus x raised to the negative 1, and then we have here plus f function of y is equal now to c minus c1 minus c2 minus c3, in which this is just equal now to our constant c, okay? So we may simplify this one into x minus x raised to the negative 1 y squared minus x raised to the negative 1 plus your f function of y is equal now to constant c, and we will denote this one, no, as our equation number 1, okay? So after that one, we are going to use the second one, no, this integral of n, okay? So using the integral of n dy plus j as a function of x is equal now to c, okay? So we use this n, no? So the integral of your 1 minus 2 x raised to the negative 1 times y, and then this is dy plus your j as a function of x is equal now to c, okay? So we distribute the integral, no? So this would be integral of your dy minus, so we extract this 2 x raised now to the negative 1 integral of y dy, okay, plus your j as a function of x is equal now to c, okay? So after that one, we are going to get, no, the integral of their respective terms, no? So we have here the integral of your dy is just equal now to y, no? So y, integral of dy is just equal now to y plus constant, no? So our last constant is let us assign this, no, as our constant one for this term, no, plus c1, okay? And then minus 2 x raised to the negative 1 times the integral of y dy, so u to the n, no? So it is equal now to u to the n plus 1, so this is y, n plus 1 is 2, no? This is 2, this is 1, so 1 plus 1 is 2 over 2 plus c2, okay? And then we have here plus your j function of x is equal to constant, okay? So 2 is eliminated here, no? So we have this y plus c1, we have here minus, no? We distribute this x raised to the negative 1 to this y squared, no? So this is minus x to the negative 1 y squared, and then minus c2 x raised to the negative 1, and then plus we have this gx equal now to C. So we separate now the constant. So this is y minus x raised to the negative 1 y squared minus this. So we have here plus this is plus, no, plus j as a function of x equal now to c minus the c1, and then after that is minus, this is minus and this is plus, no, plus our constant c2 x raised to the negative 1. Okay, so actually you may wonder, no, why is it that these terms here, no, for the constant, why this c2 x raised to the negative 1 is considered constant? Because here when we are considering, no, the integral, no, the integral of this given, no, so with respect to y, we let, no, this y as our variable. So any other variables except this y are all considered constant. So that is why from here, no, this is just the result of this 2x raised to the negative 1 integral of y dy. So our variable here is y. So we will consider this x, no, as a constant. So that is why here we transpose this one, no, to the constant side, where we only consider, no, this y as our variable. So if we assign, no, if we assign c is equal now to our c minus c1 plus c2 x raised to the negative 1. So we can simplify this one into y minus x raised to the negative 1 y squared, okay, plus j function of x is equal now to our c. Okay, so do not make it as a problem, no. You can actually sign, no, if this involves a lot of constants, so you may assign, no, constant c equal now to those constant, no. So it's not a problem, no. You just assign a single constant c equal to those constants present in the set equation. Okay, so after this we may rewrite this one into this form, no, and then this we considered as our equation number 2. Okay, so now we have now these two equations, no. So we have equation 1 and we have here equation 2. Okay, so we may rewrite this equation 1 here, x minus 1 y squared minus x raised to the negative 1 plus f as a function of your y is equal to c. So this is our equation 1, no? And let us erase this one, no? Okay, so proceeding now, so we have to use now these two equations, no? So using equation 1, okay, so we have here this x minus x raised to the negative 1 y squared minus x raised to the negative 1 plus f function of your y is equal to, says you are going to determine, okay, determine the f as a function of your y in the equation number 2. Okay, you're going to determine that this f as a function of y in equation 2. So your f as a function of y, this one refers to those terms, no, refers now to those terms that only involve, no, the y variable. Okay, so terms or term that only involve, no, or involves, okay, the y variable alone. Okay, so in equation 2, as you can see here, so we have this equation 2, no, y minus x raised to the negative 1 y squared plus j as a function of your x is equal to c. So how will you know the f function of y in this equation 2? Okay, so before we will proceed, no, let us rewrite first these two equations, no. So for equation 1 we have x minus x raised to the negative 1 y squared minus x raised now to the negative 1 plus your f as a function of y is equal to c, and this is our equation 1. Equation 2 is y minus x raised to the negative 1 y squared plus j as a function of x is equal to c, and this is our equation 2. Okay, and proceeding now, so from this is our equation 2. Okay, this is our equation 2. So how will we determine the f as a function of y? So take note that this refers now to the term or terms that only involve or involves the y variable. So in this case, the first term, so we have the y variable, so it's okay. Okay, the second term, so we don't have, no, because it involves the x and y variables. And also for the third term, so only this y variable only. So we can say that your f function of y is just equal now to the y. Those we can say, okay, those we can say that from, since we are using the equation 1, so we can say that this f function of y is just equal now to y. Those we can say that x minus 1 y squared minus x raised to the negative 1 plus f function of y is equal to c is just simply equal now to x minus x raised to the negative 1 y squared minus x raised to the negative 1 plus your y is equal now to c. Okay, so this will be then our answer using the indirect solution. Okay, so take note that they are the same, no, with this x minus x raised to the negative 1 y squared minus x raised to the negative 1 plus y is equal to c. Okay, and another one is if you're going to use first, no, the second equation, take note, no, using the equation number 2, no. So we have here this equation number 2, y minus x raised to the negative 1 y squared plus j as a function of x is equal now to c. Okay, so after that we are going to determine, no, we are going to determine the j as a function of your x then, no. So from here, since this is the j as a function of x, so we are going to determine the j as a function of x in equation number 1. Okay, so our j as a function of x, this refers now to those terms, no, or term that only involve, no, or involves, that only involve or involves the x variable. Okay, so in this case, determine the j as a function of x in equation 1. So from equation 1, so we have this x minus x raised to the negative 1 y squared minus x raised to the negative 1 plus f as a function of y is equal now to c. Okay, so by this we are going to determine now the j as a function of your x. Okay, so our j as a function of x is just equal to, so this is x. Okay, so this is x, and then the second term x and y, so this will not, no, this is not being considered. Also this one, so only x variable, so minus x raised now to the negative 1, and f as a function of y, so there's no variable x here also as on the right side, no, of this equation. So we can say that our j as a function of x is just equal now to x minus x raised to the negative 1. Those we can say, no, we can say that our y minus x raised to the negative 1 y squared plus gx is equal to c is just equivalent now to y minus x raised to the negative 1 y squared plus your gx, which is x minus x raised to the negative 1. Okay, equal now to c. Okay, and this will be then also equal to y minus this x raised to the negative 1 y squared plus x minus x raised to the negative 1 equal to c, and subsequently we are going to simplify this one, no? So this would also be equal now to, so we have now this x, no, so we may write it here x, this one, and then this minus x raised to the negative 1 y squared minus x raised to the negative 1 y squared, and this minus x raised now to the negative 1, and this y, no, plus y is equal to c. Okay, so this will be then our final answer. So take note, this is just the same for this direct solution, which is x minus x raised to the negative 1 y squared minus x raised to the negative 1 plus y is equal now to c. Okay, so you have a lot of options, no? If ever we will encounter a non-exact differential equation which cannot be solved by variable separable homogeneous equation, and you may check, no, if that is exact. But if it is not an exact, you need an integrative factor to make it exact, and then after making that differential equation into an exact equation, you may opt not to use the direct solution, or you may use the indirect solution, arriving at the same answer, no, with this x minus x raised to the negative 1 y squared minus x raised to the negative 1 plus y is equal now to c. Okay, so I hope, no, you've learned a lot today from our lecture, no, and then I hope that you find this lecture video of mine clear, no, a clear one in understanding of solving non-exact differential equations. Okay, so that would be it, no, for this day. And for our next topic, no, we are going to discuss the first order linear differential equations, or what we call this one as full day. And please don't forget no to subscribe to my YouTube channel so that you can be notified no if ever I will upload another lecture videos, not only considering differential equations but also any other subjects no in our field of engineering. So these are my references also: Rinbel, Denagli, and De La Fuente. And once again, thank you very much for listening and watching. God bless us all and keep safe, everyone.